Hello, आवाज येतोय? So in last lecture I have discussed with you that how the aromatic electrophilic substitution reaction takes place uh, by electrophile, how it is attacked on the benzene molecule, and why benzene produces different types of aromatic electrophilic substitution. In last lecture I have discussed with you regarding the nitration reaction and different types of mechanistic steps involved in the nitration reaction. Along with this one, I have also discussed regarding the halogenation reaction of benzene. Halogenation takes place by using chlorine or bromine, or iodination uh, will be takes place only in the oxidizing presence of oxidizing agent. But without oxidizing agent, iodination is not possible. Fluorination is also not possible because fluorination is a highly vigorous reaction, and that's why fluorination not takes place on the benzene molecule. So next point from your syllabus is sulfonation of benzene. So first of all, I will discuss with you what is meant by sulfonation. Sulfonation,
Hmm?
sulfonation means
Yes, yes.
when benzene molecule reacted with fuming sulfuric acid. Now question is that what is meant by fuming sulfuric acid? Sulfuric acid when mixed with saturated sulfur trioxide. Just you check here. Sulfuric acid, concentrated sulfuric acid is mixed or saturated with sulfur trioxide. Sulfur trioxide is another chemical, sulfuric acid is another chemical. So when this sulfur trioxide is added over this sulfuric acid, then the resultant mixture is called as fuming sulfuric acid. This fuming sulfuric acid is reacted with the benzene molecule at the room temperature to produce benzene sulfonic acid as a byproduct. Please mute your phone. All are informed that please mute your phone. Benzene, benzene reacts with sulfuric acid, that is fuming sulfuric acid is used to conduct the sulfonation of benzene. Now, sulfonation also takes place in concentrated H2SO4. Now, question arises that can we perform the sulfonation reaction without use of sulfur trioxide? If you use only sulfuric acid, what happens? If you use only sulfuric acid, the reaction is very slow. Reaction is very slow. That's why we are using sulfur trioxide. If this reaction will then reaction will be performed very fast in the presence of sulfur trioxide. So sulfur trioxide acting as a electrophile here increases electrophilicity of the sulfuric acid also, and that's why sulfur trioxide is used to conduct the sulfonation of benzene. Just you see here, when benzene reacted with sulfur trioxide, then this reaction is conducted at 25 degrees centigrade, and the product is benzene sulfonic acid. Product is benzene sulfonic acid with 50%, 56%. Now, how the mechanism takes place during the sulfonation reaction? Just to check here. Many times in the question is asked in the for the long answer question. Discuss the mechanism of sulfonation reaction. So first of all, in first step, what happens? Just reaction. There is a reaction between sulfuric acid and sulfur trioxide. This is the sulfuric acid H2 and S O. How many times O is there? 4 times. So this is H2SO4. I am written here H2SO4 in different way, different fashion. You don't confuse with this one. So this is H2SO4. Now this H2SO4, when we mix it with sulfur trioxide, what happens? One of the hydrogen will be abstracted, escaped by this SO3 molecule. This hydrogen will be goes to this SO3. What happens? SO3H will be the product. Okay, S O O O and H, that is SO3H. Now either now this SO3H having a positive charge. This SO3H called as sulfonium ion. SO3H called as sulfonium ion. This SO3H called as a sulfonium ion, and this sulfonium ion having a positive charge acting as a electrophile, acting as a electrophile because it possesses a positive charge. with elimination of HSO4 negative. HSO4 negative. Now, our main target is to produce the electrophile SO3H with positive charge. And it will be produced, it is produced in step first with reaction of sulfuric acid and sulfur trioxide. Now, electrophile is generated in this step. So, this generated electrophile will be attacked or will be reacted with the benzene molecule, and this is called as the addition of electrophile over the benzene molecule. So this benzene molecule will be bombard or attack on this positively charged electrophile of sulfonium ion. Again, there is a formation of a sigma complex. Just in previous lecture I have told with you that how arenium ion or Wieland complex, or you can call it sigma complex, is formed if electrophile will be attached on the benzene molecule. So initially the benzene molecule creates positive charge. Again, there is a SO3H will be here, and the positive charge will be nullified due to delocalization of due to delocalization of pi bond here, shifts here. Again, positive charge is here, and to neutralize this positive charge, this bond will be shifted here. I am shown by the green colored arrow here. Again, positive charge is developed here. One of the carbon is sp3 hybridized, but remaining carbon are sp2 hybridized. Now, these three structures are called as the resonating structure or sigma complex structure, or you can call it the Wieland complex structures. And finally, we can write this is a hybrid structure of this sigma complex. In this hybrid structure, positive charge will be delocalized from one position to another position, and here one of the carbon is sp3 hybridized, at which carbon one of the proton is there, as well as electrophile SO3H is attached here. Now this is the step second. In step first, generation of electrophile. In step second, hybrid structure of benzene molecule with sulfonium ion or sulfonic acid. Now in the last step is very important. This last step is called as a loss of proton, elimination of proton. And because due to loss of proton, benzene molecule gets aromaticity. Means initially this is not aromatic compound, but if the proton is loosed from this structure, benzene gets restored, regains its aromaticity as it is in the as it was in the previous case. So in the final step, one of the proton is eliminated to neutralize the positive charge on the benzene molecule, and third bond is formed here. Third bond is formed here. As there is a formation of a third bond, third pi bond here, aromatic sextet is possible, and as there is aromatic sextet, benzene is stable. Okay, and that's why benzene sulfonic acid is formed in such a way during the transformation through these three steps. Now this again H2SO4 is there. You can I have shown here HHOSO3S. This is called as H2SO4 commonly. I have written in different way, but this is H2SO4. Now the main product benzene sulfonic acid is formed during this reaction mechanism, as I have discussed with you during these three steps. First step, generation of electrophile. Second step, hybrid structure of sulfonium ion with benzene. In the last step, loss of proton and restoring of the aromatic characteristics of the benzene molecule. Now I am shifting to next point from your syllabus, that is Friedel-Crafts reaction. Why the name is Friedel-Crafts? The two scientists was there. One of the scientists is Friedel, another name of the scientist is Kraft, and both scientists have discovered that reaction. So the name of that reaction is Friedel-Crafts reaction. This Friedel-Crafts reaction is divided into two categories, or two types of the Friedel-Crafts reactions are there. First category is Friedel-Crafts acylation reaction. Second category is Friedel-Crafts alkylation reaction. So one by one, I will discuss with you that what is the meant by, or how the reaction, that is Friedel-Crafts acylation takes place, as well as how the reaction Friedel-Crafts alkylation takes place. Initially, I want to discuss with you regarding this acylation or Friedel-Crafts acylation of benzene. So what happens in the acylation of benzene? Now the word acylation suggests us that there is an acyl group. What is meant by acyl group? COCH3 group is known as a acyl group. If there is a attachment of COCH3 group to the benzene molecule, that type of reaction is known as acylation of benzene. So to conduct the acylation reaction, we must use a reagent, appropriate reagent, suitable reagent. Which is that? That is, that acylating reagent might be, yes, acetyl chloride, or sometime we can use acetic anhydride. Both acylating agent we can use for the, yes, conversion of acylation of benzene molecule. So I have written here benzene, when benzene in the presence of Lewis acid like anhydrous aluminum chloride, when benzene reacted with what type of acid? Lewis acid like anhydrous aluminum chloride, like reacts with acetyl chloride. Now here already I have discussed in previously that for the acylation reaction we can use acylating agent. We must use acylating agent. Which are the acylating agent? Either you can use acetyl chloride or either you can use acetic anhydride. So benzene reacted with anhydrous aluminum chloride as a catalyst, that is Lewis acid as a catalyst. Now who is second reactant? Second reactant might be acetyl chloride or acetic anhydride. You can use anyone at 80 degrees centigrade, and benzene as a solvent, and to form the product is acyl chloride, and that is acetophenone. If benzene is reacted with acetyl chloride, then the product is acetophenone. In the same case, same benzene, but the acylating agent is acetic anhydride, catalyst is anhydrous aluminum chloride, the product is also same. In this case, the product is acetophenone. In this case also, the product is acetophenone. In this case, the byproduct is HCl or hydrochloric acid, but in this case, the byproduct is acetic acid. Only difference in the byproduct. But in both the reaction, the product is same, acetophenone, or you can call it as a phenyl methyl ketone. This is a phenyl methyl ketone or acetophenone, or you can call it as a 1-phenyl ethanone. All the names are same. So this reaction is called as a acylation reaction. Again, I am repeating in short that benzene when reacted with, yes, reacted with acetyl chloride or acetic anhydride in the presence of Lewis acid like aluminum chloride as a catalyst at 80 degrees centigrade, benzene as a solvent, what will be the probable product? Probable product or product is acetophenone. So we can use both acylating, we can use any one acylating agent. Either you can use acetyl chloride or either you can use a acetic anhydride. I have shown in the reaction that this is acetylating agent. Acetylating agent, acetyl chloride reacted with benzene molecule, which is aromatic compound. Lewis acid as a catalyst, that is aluminum chloride, and we are getting acyl group is added here. What is meant by acyl group? That is COCH3 group is known as the acyl group, is added to the aromatic compound known as the Friedel-Crafts acylation reaction. Byproduct is hydrochloric acid. Now in this case, just to check, when benzene molecule reacted with acetic anhydride, second acylating agent, or this acetic anhydride might be called as ethanoic anhydride in the presence of same catalyst anhydrous AlCl3. Product is acetophenone, or you can call it as 1-phenyl ethanone, another name of acetophenone. But the byproduct is, instead of hydrochloric acid, we are getting acetic acid. Now I will show to you how the mechanism takes place. Now friends, just to check here, this is RCOCl or acyl chloride reacted with aluminum chloride. Now this Cl goes to AlCl3. What will happen? AlCl4. Initially the chlorine was 3, and this one chlorine is added to this AlCl3. Now how much chlorine was there? Is here AlCl4. AlCl4. Now what remains? R, C and O remains. Okay, I have shown here R, C and O. Only H is eliminated from this one. Okay, so AlCl4 is there. R, C double bond O with positive charge. Now this carbon is positively charged, means electrophile. Okay, this is the electrophile, and just we are studying that which type of reaction we are going to discuss? Electrophilic substitution. So in each and every case, remember one thing is that first step is generation of electrophile. First step is generation of electrophile. In this case also, acyl chloride reacted with catalyst aluminum chloride to form the electrophile. That is, electrophile is acylium ion with having positive charge. So this H is toward this AlCl4. Now RCO with positive charge is formed. This is called as a acylium ion, or ArC double bond O with positive charge. Now once, or in first step, there is a formation of acylium ion. This acylium ion reacted with benzene molecule. Benzene having a full pi electron cloud will be easily attacked on the carbon of positive charge. Okay, carbon of positive charge. Now the structure is like this. This step is very slow. That's why this step is called as a rate determining step. Okay. Now positive charge is here, and now in the second step, that is first step reaction, already in last slide I have shown with you that this elimination of hydrogen is there. Who eliminates this hydrogen? Base eliminates the hydrogen. Who is the base? AlCl4, which is prepared in first step. This AlCl4 is used here, which is acting as a base to eliminate the proton, to escape the proton, to abstract the proton from this, yes, ring carbon atom. This H will be goes to AlCl4, and the bond is this ring carbon and hydrogen containing bond shifts here and new bond is formed. So initially in this structure, how much bonds? Two double bonds are there. Now in this case, three double bonds are there. Now aromatic characteristics is retained in case of benzene molecule. So if R is equal to CH3, if you put CH3 here, the structure is acetophenone. Okay, structure is acetophenone. The product or byproduct is hydrochloric acid as well as AlCl3. Now this AlCl4 and one of the hydrogen is there, HCl, H from this one, Cl, one Cl from this one, HCl as a byproduct, and AlCl3 is also byproduct. So benzene reacted with acylium ion, slow step, rate determining step, formation of a rhenium complex or rhenium ion. Second, abstraction of proton, very fast step, not a rate determining step, and formation of a acylated compound. If R is equal to CH3, then it is called as a acetophenone or 1-phenylethanone as a major product. So next reaction, I have just shown in the first slide, there are two types of the Friedel-Crafts reaction. One is a Friedel-Crafts acylation, another is a Friedel-Crafts alkylation. So we are going to discuss about the alkylation. Now in the first slide, in the first reaction, that is acylation, I have put in front of you the meaning of acylation. Similar to that of, I want to share the meaning of alkylation. Acyl group, if acyl group is attached during the reaction, called as acylation. Similar to that of, if alkyl group, ALKIYL, alkyl group, any alkyl group means methyl, propyl, ethyl, butyl, pentene, whatever it may be. These groups are called as a alkyl group. If alkyl group attached to the aromatic compound, that type of reaction called as alkylation of aromatic compound. If alkyl group attached to benzene, that reaction is called as a alkylation of benzene. Alkylation of benzene. So during the alkylation reaction, alkyl group is inserted and alkyl group is substituted to the benzene molecule. Alkyl group is attached to the benzene molecule. That reaction called as a alkylation of benzene. So what we requires? We requires benzene molecule as a reactant. Second, what we requires? Alkylating agent. Alkylating agent we require. Same catalyst we are using here also, which is used in the acylation reaction. In the acylation reaction, we have used anhydrous AlCl3 as a catalyst. As a catalyst. In this case also, we are using same catalyst, that is anhydrous AlCl3. But only we have to change the alkylating agent. Here, in the case of alkylation of benzene, you can use different type of alkylating agent, either methyl chloride, yes, ethyl chloride, pentyl chloride, butyl chloride, like this, or tertiary butyl chloride. You can use different types of alkylating agent. Here, as a representative case or representative example, I have put here one of the example of a alkylation reaction of benzene. When benzene in the presence of anhydrous aluminum chloride reacts with alkyl halide to form the alkyl benzene. Now Lewis acid, that is AlCl3, is used to enhance means to increase. AlCl3 is used to increase the electrophilicity of alkylating agent. Now why we are using AlCl3? AlCl3 increases the electrophilic power. Are you clear? AlCl3 increases electrophilicity, means electrophilic power means strong positive charge is generated if you add AlCl3. If you remove AlCl3, there is no strong positive charge is generated, and that's why we are using AlCl3. So AlCl3 acting as a catalyst to enhance, to increase the electrophilicity of the alkylating agent. As an example, I have reported here, benzene in the presence of anhydrous AlCl3 reacts with methyl chloride. Very simple, methyl, CS3Cl we are taking here, CS3Cl we are taking. So instead of CS3Cl, you can take C2H5Cl also, what is called ethyl chloride, or you can take propyl chloride, or you can take ethyl, any ethyl group containing any alkyl group containing chlorides. So benzene reacted with anhydrous AlCl3 as a catalyst in the presence of methyl chloride. What will be the product? The product will be methyl benzene. And you know that methyl benzene commonly known as a toluene, commonly known as a toluene. Just you see here, friends, when benzene is here reacted with methyl chloride, AlCl3 as a good catalyst to enhance the electrophilicity of the alkylating agent. And just what happens on this benzene molecule, one CS3 gets attached, and this Cl is eliminated, and H from hydrogen, that is H hydrogen from this benzene gets eliminated. One H from benzene and one Cl from CS3Cl. The product is a byproduct is HCl. Now, during this step, benzene is alkylated, means alkyl group is attached to benzene. So, this reaction is called as the alkylation of benzene, and thus, as it is discovered by the Friedels and Kraft, so this reaction is called as a Friedel-Kraft alkylation reaction. Okay. So, just we want to share with, I want to share with you the mechanism. This mechanism of this Friedel-Kraft alkylation reaction involves three steps. Now, as in previous case, I have discussed with you that in each and every electrophilic substitution reaction, first step is generation of electrophile. Okay. Similar case, in step 1, there is a generation of electrophilic methyl carbonium. Just this AlCl3 reacts with CS3Cl. One of the Cl is attracted to AlCl3, then in the formation of AlCl4. Now this CS3 becomes positive charge. Okay. This CS3 becomes positively charged. Now this CS3 or positively charged CS3 will be attack on the benzene molecule in the step 2nd, and in step 2nd, the CS3 attack on benzene molecule, formation of a arenium ion, formation of a arenium ion, or Wheeland complex, or you can call it as a sigma complex, which is, yes, which is formed in step 2nd. This step is very slow step. This step is rate determining step. Okay, step 2nd. Now in step 3rd, there is abstraction of proton from the arenium complex or sigma complex or Wheeland intermediate. So step 3 is the abstraction of proton or H plus charge from the sigma complex to form the electrophilic substitution product to retain the aromaticity of the benzene molecule. So in the last step, that is step number 3, there is abstraction of a proton by this AlCl4, which AlCl4 is prepared in step 1st, having a negative charge acting as a base. This AlCl4, yes, attacks on this proton to escape the proton from the benzene molecule, and the bond between ring carbon and proton gets delocalized, gets shifted in the benzene molecule, and third pi bond is formed to regain or to retain the aromaticity of the benzene molecule. And last step is the aromatic substitution product is formed, and this product is called as a methyl benzene, or toluene is the final product. In this step, the stability will be regained or retained by the loss of proton, and third bond is formed. So this third step is very important, and this step 3 is very fast step reaction. We cannot determine the rate of this step 3. So this step is not a rate determining step as step 2nd is rate determining step, because it is a slow step reaction. So this is all about the alkylation of benzene. Again, I am repeating in short. When benzene in the presence of anhydrous aluminum chloride reacts with alkyl halide to form the alkyl benzene. Now Lewis acid or AlCl3 is used to enhance or to increase the electrophilic power or electrophilicity of the alkylating agent. Instead of using AlCl3, if without using AlCl3, AlCl3 reaction will be conducted, but rate of reaction is very slow, because electrophilic characteristics of CS3 positive is not strong, and that's why CS3 positive not generated properly, and thus positively charged carbocation does not attacks on the benzene molecule, and thus speed of reaction will be very slow. And to increase the speed of reaction, we must use anhydrous AlCl3 acting as a catalyst, that is Lewis acid as a catalyst. For example, I have reported here, when benzene in the presence of anhydrous aluminum chloride as a catalyst react with methyl chloride, that is CS3Cl, as a alkylating agent, alkylating agent to form the methyl benzene, or you can call it as a toluene as a final product. In first step, generation of a carbocation, that is electrophile. In second step, attack of electrophile on benzene molecule and formation of a rhenium ion or valent complex. And in third step, the abstraction of proton to form the sigma from the sigma complex to get the electrophilic substitution product or highly stable product during the electrophilic aromatic electrophilic substitution reaction. So in this way we have completed the chapter uh, arenes and aromaticity. In this arenes and aromaticity, we have discussed about the what is meant by arenes and what is meant by aromaticity, that is the introductory part. Nextly, we have just discussed about the nomenclature of aromatic nucleus. Nextly, we have just shared with you that the how aromatic electrophilic substitution reaction takes place, what is the concept of aromaticity, Foucault rule, how we can decide the aromaticity on the basis of Foucault rule, and some other concepts are also there. Along with this one, we have discussed about the nitration reaction, sulfonation reaction, halogenation reaction, as well as Friedel-Crafts acylation, as well as alkylation reaction. So I will share all the videos also with you by providing you a one link. If you click to this link, you can watch these videos regarding this arenes and aromaticity. I will provide detailed notes also on your WhatsApp group. So if you have any doubt, please ask me. So thank you for your attention.